Hi everyone. So my problem that I was assigned to is number 6 for chapter 2. It focuses on motion in one dimension. And the question I was assigned to was starting at 48th Street, Dylan rides his bike due east on Meridian Road with the wind at his back. He rides for 20 minutes at 15 miles per hour. He then stops for 5 minutes, turns around, and rides back to 48th Street. Because of the headwind, his speed is only 10 miles per hour. Part A asks, how long does this trip take? And Part B, assuming that the origin of his trip is at 48th Street, draw a position versus time graph for his trip. So, given the knowns, we know that at the origin is 48th Street, so the initial position is 0. So then he travels 15 miles an hour for 20 minutes. That's initial velocity or speed. And then going back, his speed is only 10 miles per hour. And between the transition between 15 miles an hour and 10 miles an hour, he stops for 5 minutes. So in order to calculate, you would have to, since we are given the knowns, we would want to figure out the time. So the first part is how I would describe to do some cross multiplication. We know that the initial is, we have to figure out the amount of distance that Dylan traveled from the initial position to 20 minutes later. And so in order to calculate that, you can see that I took 15 miles right here and converted the units so that I can get miles by itself by multiplying hour by 60 minutes, and we know he rode for a total of 20 minutes, and by this multiplication we ended with 5 miles. So we know that in 20 minutes, as Dylan was riding for at 15 miles an hour, he rode for a total of 5 miles. So now that we know the number of miles, we can use that to calculate the amount of time that he traveled going back to 48th Street, or to his origin. And so by taking the miles, I also followed the cross multiplication rule. So we know that for 5 miles, and his changing speed is only 10 miles per hour. So in order to remove the miles, I flipped the hour to miles so that I can get rid of the miles. And then to convert the units back to minutes, we know that there's 60 minutes per every hour. So that totals to 30 minutes. So going from the stop, from his position when he stopped for 5 minutes to going back to 48th Street was a total of 30 minutes. So in order to calculate time, we know the time that it took for him to travel 5 miles, and we know the time that it took him to travel from the 5-mile position point and back toward 48th Street. So what I essentially did was added the total amount of time that it took for his trip based on my known values. And so it ended up being taking the initial 20 minutes plus the 5-minute wait plus the 30 minutes that it took to get from his new position and back towards 48th Street, and that totaled out to be 55 minutes. Therefore, his trip took 55 minutes to travel. So the second part of the question asks, assuming that the origin of his trip is at 48th Street, draw a position versus time graph for this trip. So the position in this case is x because it's traveled horizontally. Time is in minutes. And so the origin is 0. This is where he started. So he travels up for 5 miles. And that takes around 20 miles an hour, or about 20 minutes. And so he delays for 5 minutes. Therefore, there's a constant slope right there. And so because the time that he takes is a lot slower, coming back to the origin, which is 48th Street, the slope is a little less steeper. but he is going in the negative direction. Therefore, this is the position and time graph of the problem.